Hello guys, I'm back. Welcome to the Chemical Process Engineer Diary. In this series, I share with you my daily life as a chemical process engineer. And in this video, I will comment a question that I received from one of my students in the In-Process Booster training program. And it is related to the compressor selection. So stay with me up to the end to verify how to deal with this in the real world. My name is Jeferson Costa, and I teach students, graduates, and engineers how to work with chemical process engineering and plant design. In the In-Process Booster training program, the students are able to share their questions with me, and this week I received the following question. We have a reciprocating compressor for this service, but maintenance and breakdown is high, so I want to convert into centrifugal compressor. So is it possible? I don't think it will be possible, as you said, centrifugal compressor will work on high flow. So as you can see, this is a reply from a previous answer that I give to him, and based on that, I listed 6 topics to be reviewed by my student. And I will get this opportunity to share these 6 topics with you and also additional comments. Just before talking about the 6 items, let's take a look on this chart. Most often on textbooks, we learn that for high flow and low pressure, we should consider dynamic compressors like centrifugal compressors, and for low flow and high pressure, we should consider reciprocating compressors. But what is high flow? What is high pressure? What is low flow? What is low pressure? On this chart, you can have a reference. So this chart is in actual cubic feet per minute and also PSIG. So the first thing to observe is that when we are dealing with the design of a compressor, most often we identify the flow based on a set of pressure and temperature, like standard flow, like normal flow. So most often you will see a compressor for 2000 normal cubic meters per hour or 2000 standard cubic meters per hour. And that means you have set the conditions of temperature and pressure. And the conditions of temperature and pressure not necessarily is the same as your process conditions. So when we have a compressor or a rotating equipment that is identified as the actual cubic feet per minute, it means that the process conditions for pressure and temperature is your operating conditions. If it is 40 Fahrenheit or 15 PSIG, it will be the conditions for the actual volume flow. And it's important because when you do the conversion for normal cubic meters or standard cubic meters, the values can be very, very different. So this is the first point. So based on that, you can see that as you increase the actual volume flow, you pass from the boundaries of the reciprocating compressor. So here we have different boundaries according to different types of compressors, and there is no absolute truth. So here, as we increase the flow, you can see that the chart indicates the use of the actual compressor, for instance. And based on this delimitation placed here in the chart, we can have an indication of best flow and the usual discharge pressure also. So we have here an indication of the use of the actual compressor. There are another place here, a delimitation place here for the use of centrifugal multi-stage compressor. So based on this range, you should evaluate, or you should consider the use of a centrifugal multi-stage compressor. But there are a boundary, there is an interface between the reciprocating multi-stage compressor and the centrifugal multi-stage compressor, where both of them could be used. And so on, you can see there are a delimitation for reciprocating compressor single stage, centrifugal compressor single stage, and etc. So with this chart, you have the first tip on how to choose the rotating equipment that you need for compressing gas. And now that you have this point of view, or that you have this information, let's take a look in the 6 items that I shared with my student. So my first tip, considering that the compressor is already installed and in operation, but he is facing problems with the breakdown of the equipment, is to verify if the current operating conditions matches with the specification datasheet of the compressor. What I mean by that? When we do plant design, we design the compressor for the design conditions of temperature, pressure, and flow, and composition of the fluid. But once the compressor or the equipment is installed and the commissioning startup and plant performance of the plant is finished, the operation of the equipment goes to operations team or to operation personnel. And it's not uncommon, and sorry guys, it's the truth, that the operations do the operation of the equipment outside of the range of the design. And why they do that? They do that because they want to achieve the maximum or the maximum allowable production with the minimum required cost. This is normal, this is what happens, and if we don't operate the machine in the boundaries of its specification, of course that the breakdown will increase, although the quality of the equipment is high. So this is a point very, very important to be observed if you are in an old plant or if you are in a new plant. When I was dealing with a liquid CO2 plant installation, we were adding a new compressor for the project, and although the specification was operating the compressor at 14 bar G, for instance, the operations increased the set point of the pressure control until it was, for instance, 14.5, and no problem, it's operating, it's not having any kind of issue, so let's keep it this way because my transferring of liquid will be in a higher rate to the storage. So there are things you are not able to solve. This is the way that the plant is performing the operations, but we cannot blame or comply with the performance of the equipment if it's not under the boundaries of the design. So before thinking that is the fault of the supplier that you have too much breaks or too much maintenance to your equipment, first verify if your specification datasheet and your operation conditions matches. If it do not matches, let's see the second item. So the second item that must be considered when we are dealing with the equipment issues is to do or to update the specification datasheet of the equipment to the current conditions of the equipment, or eventually for the expected future conditions of the equipment. Because this way you will guarantee that once you get in touch with the suppliers, and we'll talk about that in the next items, you will be able to choose the correct equipment to the correct conditions. We will not buy a new equipment that can be hundreds of dollars or millions of dollars based on emails exchanging. So if we are talking about plant design, if you are a chemical process engineer that wants to do the right work in chemical process engineering and plant design, you must fill at least the process datasheet of the equipment. And there are a few differences between the process datasheet of the equipment and the specification datasheet of the equipment. When we are talking about the process datasheet of the equipment, mainly we are adding information related to the process conditions: pressure, temperature, flow, and composition of the fluid. This is the minimal required information to purchase our equipment. But that most often is not enough to guarantee the performance and the conditions of your equipment. So based on that, the mechanical engineer most often, or the equipment engineer, based on the process conditions, will define the material of the equipment, will define some tolerances of the equipment in order that the supplier have a commitment to achieve those conditions. When we are talking about rotating equipment, most often they use some kind of source of energy to run, and usually is electricity. So instead of besides the chemical process engineer, besides the equipment engineer, we will have also the interface of the electrical engineer, because he or she is the best person to define information related to electricity, like motors, cables, and etc. Another engineer that can be involved in this task is the control engineer, because most often our process is automated. We have controls for the suction, for the discharge. We have some kind of trips to the machine to keep the safety of the plant and also of the machine. So it's important to the control engineer knows what kind of communication will be possible between the machine and also the supervisory of the plant, or the machine and the PLC of the plant. So as you can see, we have a multidisciplinary involvement when we are talking about the specification datasheet of the equipment. That is different from the process datasheet of the equipment, that most often is a job only of the chemical process engineer. If you are in a big company with junior, seniors, and others levels of engineers, and you are in the lower position, your process datasheet will be reviewed by a senior engineer. If you are the only one, everyone will trust you that you are doing the correct job, and the other discipline will do their job based on yours. And with that, we can go to the third item. Once you have your process conditions defined, like pressure, temperature, flow, and composition, and with the chart that we have seen previously, we are able to do the pre-selection of vendors using, for instance, the internet or the LinkedIn. So every time that I need to deal with a new equipment in plant design and I don't have a vendor list for that, what I do is go to internet for looking for possible vendors that are able to supply this kind of equipment to me. So there are companies specialized in reciprocating compressors. There are companies specialized in centrifugal compressors. There are companies specialized in pumps, in heat exchangers, in vessels, in etc. So you need to go to the internet, because it's the easiest way to find possible suppliers for your equipment. Depending on how big is your company, you will get the specification datasheet, give it to the procurement team, and wait for the answer. If your company is a medium to small company, or if although it is a big company but have a small engineering design department, I recommend you to do this task. Why it's important to you do this job instead of procurement? Because before being able to purchase the equipment, talking about fees, you need to do the technical approval of equipment. And to do that, it's easier if you short the path between you and the vendor, because before selecting equipment, it's important that you clarify a lot of questions related to the technical conditions of the equipment. In fourth item, or in the item 4, my recommendation to you is to do the download of catalogs and selection software available by the vendors. The first part, you identify the main vendors are able to supply you with the equipment, But now you need to go inside the product specifications and verify if in fact they are able to supply you with the equipment with the range of operation that you need to. And to do that, there are many ways. As we have talked, it's important to use the internet. You can use the Google and also the suppliers' websites, or eventually you can use also the LinkedIn. So based on that, you need to get the catalogs, and most often it can be downloaded as PDF files, or you can use the information available in the website of the vendor. And there are some vendors, depending on the kind of equipment that we are talking to, that offers to you for free the access for pre-selection softwares. It can be a file to be downloaded to your computer, or it can be an online tool that you, with registration, you are able to access. In any way, the fourth item, the main objective is now to do a short list of vendors in order that you are able to identify which of them in fact are able to supply the equipment with the characteristics that you need to. In item 5, my recommendation to you is to get in touch with the vendors, proposing an online meeting with them in order to build the relationship and also to share the problems that you are facing. Why this is important? First thing is that sometimes you don't have all the information needed, or you don't have the experience enough to verify all the conditions of your problems. And when you talk with experienced suppliers, they can give you some kind of tips or new point of view to solve the problems or to propose solutions for what you are facing. Another thing is that when you talk with someone by online, you are closing or you are building a relationship. So the chances to receive a quotation and a faster quotation increases, especially if you are talking about medium to small companies and you don't have a history of relationship with the new supplier. So it's important to you present the company, understand what are the servers and equipment provided by the vendor, in order that when you require a technical economic quotation for them, the vendor responsible for your account attends you in a faster way and in a more collaborative way. I like to do this kind of interface before just adding or just sending the technical specification. Even though I look for the website, I send the technical specification, I always propose an online meeting for clarifying what is asked in the technical specification. And if you are working in the other side, in the vendor side, if you are a seller, I always recommend you to talk with the customer, because sometimes the customer do not really know what they need or what kind of solution can be used for solve the problem. And if you are able to help them with the problem, it will be good to everyone. So this is a very important point. Do not be restricted to the procurement team do this kind of interface with vendors, because they are not the person responsible for the technical aspects of the solution. They are responsible for dealing with the best offer or the best negotiation with the supplier. And that leads to the sixth item, or the item 6. In item 6, considering that you have followed the previous items, you have a better understanding of your problem and also of the possible solutions offered by the market. And it's time to ask for a technical commercial quotation from the vendors. The technical commercial quotation, you will find or you will receive technical information related to your equipment, and also the commercial conditions for your equipment, like the price of the equipment. and that leads to a sensitive point, because some companies that has policies that split or disengage a technical quotation from a commercial quotation to not influence the technical decision, and also to prevent corruption. So in this way, most often the commercial quotation for high amounts of money will go only to the procurement team, because based on the commercial conditions, they will discuss with the vendor how to do that, if we will have discounts or not, and the technical team, the chemical process engineer, will have access only to the technical quotation. This is not an issue if your task is only to provide the technical solution for the company that you are working to. So you will receive, for instance, the compressor curve, the compressor performance, the guarantees that is related to the compressor, spare parts, and etc. So you need to evaluate if the technical quotation of the vendor really matches or really fits to the needs of the process in terms of pressure, temperature, composition, and flow, and also the range of operations. And with that, you will fill a technical report giving the okay for the purchase or not of that option, and adding the comments or the clarifications why you not approved that kind of solution. For instance, you receive 3 technical quotations from different suppliers, and all of them can be technically acceptable. If that's the case, you will inform the procurement team that all the quotations is valid, and based on the best price, they will purchase the machine that you need to. But eventually, from the 3 quotations, technical quotations that you receive, 1 of them or 2 of them is not technical acceptable, because they do not match any one of the characteristics of the process datasheet or the specification datasheet that you shared with the vendor. In this case, it's recommended that you have a report talking what was the consideration for not approving those vendor. This document is not for external use. You don't need to justify to the vendor why they was not approved, but for internal assessment, it's important to clarify or to make clear that it was a technical decision, and there is any kind of relationship with you and with the vendors related to commercial relationship and corruption and etc. So you guarantee that you don't have any kind of issue with the governance of the company. That is very, very important. And with these 6 steps, you can consider that your job is done if you just need to do the technical evaluation of the solutions available in the market. To finish this video, let's summarize what we have seen, and I will give it to you a 7-item bonus that will really define if we will be able to buy the equipment or to change the equipment or not. So summarize, when you are dealing with existing equipment, first thing that you must evaluate is the operating conditions of the equipment, if it matches with the technical specification of the equipment. If the operating conditions of the equipment is different from the design conditions of the equipment, and they are outside of the margin of operations, you need to go to the second step, that is update your technical specification or develop a new one, in order that you are able to look for equipment that fits to your process. And to do that, if you don't have a vendor list yet in your company or in your department, you go to the internet and identify the major companies that delivers or that offers the kind of equipment that you are looking for. If it's compressor, look for compressors company. If it's heat exchangers, look for heat exchangers companies. But that alone is not enough, because sometimes you have a lot of companies in your list and you need to do a short list. The short list will be based on the companies that can really fit your needs, and you will know that if you go to the catalogs of the vendors, or if you have access to preliminary selection softwares available by the vendors. With that, instead of dealing with 10 companies, for instance, you can do a short list with 3 to 5 companies to, in the next item, do or propose an online meeting with them. And the main objective of these online meetings with the vendors is to build a relationship with the person responsible for your account, and also to share the problems that you are facing, because based on the experience of the vendor, eventually he or she they can add a different point of view in order to help with the solution of your problem. After that, you have all the information required to update your technical specification if needed, and ask for a technical commercial quotation for the vendors. That can be a responsibility only yours or addressed to the procurement team. And with that, you will receive the technical proposal, and you need to evaluate if the vendor are really able to help you with the solution. If the equipment really matches or really fits to your needs, you will give approval and forward to the procurement in order that they are able to do the negotiation and the purchase of the equipment. In item 7, you must make sure that the purchase of the equipment makes sense. What I mean by that? Before the procurement be able to buy an equipment, they must have the capex associated to the purchase approved. If we are talking about a feasibility study, you are evaluating if it makes sense or not to purchase the equipment. And the purchase of the equipment will depend on the capex, how much is the equipment, and how much is the opex of the equipment. I have said in a previous video that you have some main key points in the opex. So you can take a look. If you are on the YouTube, you can take a look on this video here. And in general sense, you will not have the money to purchase the equipment if you do not prove to the company that it is better to have the new equipment than keeping with the existing one. If you are having too much breakup of your equipment, you need to show to your boss or to the board that you are losing a lot of revenues because of that, and that the new equipment will decrease these losses, and in 6 months, 1 year, how many years as needed, you will have this money back to the company, and with that increase the profits of the company. So no equipment will be allowed to be purchased without a technical feasibility, but also with the commercial or economic feasibility. And when we are talking about the preliminary stages of a project, in the conceptual design of a project, if you are in a medium to a small company, most often the process engineer will be the person responsible to do this kind of verification. And to do that, you will need to have access to the commercial quotation of the vendors. So in this case, you will start filling a data bank with commercial specification in order that you are able to evaluate for this kind of equipment from this size costing this much, it makes sense or not to add to my process, and with that has better performance in terms of reliability, availability, KPI, and etc. So guys, this was I would like to share with you. As I told you, it was an answer to one of my students in the in-process training program, and I was interested to share with you what is the real life of a chemical process engineer that works with blended design. This is it. I hope you like it, and I'll see you soon in the next video. Bye bye.